For hundreds of thousands of years, Earth was home to not just one, but several kinds of humans. We, Homo sapiens, were not alone. Two of our closest, most enigmatic relatives were the Neanderthals and the Denisovans. For a long time, we thought of them as primitive, brutish beings, evolutionary dead ends. But what if the story is far more complex, far more intimate than we ever imagined? What if their legacy isn't just found in fossils and dusty caves, but inside of us, written into our very DNA? Today, we journey back in time, hundreds of thousands of years into a world of ice, hardship, and incredible resilience. We're peeling back the layers of prehistory to uncover the true origins of our ancient cousins. Using the latest genetic sequencing and groundbreaking archaeological finds, we're piecing together a puzzle that fundamentally changes our understanding of what it means to be human. Where did they come from? How did they live? And what really happened when our paths crossed? Our story begins in Africa, the cradle of humanity, nearly 1 million years ago, with a common ancestor known as Homo heidelbergensis. These were skilled hunters, tool makers, and likely the first to control fire. But they were also explorers. Around 700,000 years ago, groups of heidelbergenses began to venture out of Africa. This great migration was not a single event, but a series of waves stretching over millennia. One group journeyed west into Europe and the Middle East. Over countless generations, isolated by vast distances and shaped by the harsh, cold climates of the Ice Age, they evolved. Their bodies became shorter, stockier, and more robust, a perfect adaptation for conserving heat. Their faces featured a prominent brow ridge and a large nose. These were the Neanderthals. For over 300,000 years, they were the undisputed masters of Eurasia, thriving in a world that would have been lethal for us. Meanwhile, another group of heidelbergenses traveled east, into Asia. For a long time, the story of this branch remained a complete mystery. We had no fossils, no clues. That is, until 2010, in a remote cave in the Altai Mountains of Siberia, a place called Denisova Cave. Scientists discovered a tiny fragment of a pinky bone from a young girl. It was so small, it could have been easily overlooked, but the genetic material preserved within it would rewrite human history. When scientists sequenced the DNA from that bone, they were stunned. It didn't match Neanderthals, and it didn't match modern humans. They had found a completely new, distinct lineage of ancient human, the Denisovans. This single discovery opened up a whole new chapter. Denisova Cave, it turns out, was a unique crossroads. Over tens of thousands of years, it was inhabited by Neanderthals, Denisovans, and even early modern humans, sometimes all within the same geological period. The genetic evidence reveals that the ancestors of Neanderthals and Denisovans split from our own lineage around 600,000 years ago. Then, about 400,000 years ago, they split from each other, embarking on their separate evolutionary paths in the West and the East. For a long time, we pictured these three groups as separate trees, branching off and never touching again. But the truth is far more intertwined. The real bombshell came when we compared their genomes to our own. The story wasn't one of replacement, but of reunion. Around 100,000 years ago, as modern humans, our direct ancestors, began their own great migration out of Africa, they encountered a world already populated by their long-lost cousins. And when they met, they didn't just compete, they interbred. This wasn't a rare, one-off event. It happened multiple times, in different places, across tens of thousands of years. As modern humans spread across Eurasia, they met and mixed with Neanderthals. The result? Today, almost everyone with ancestry outside of sub-Saharan Africa carries between 1% and 2% Neanderthal DNA in their genome. Think about that. A part of them lives on in billions of people today. These Neanderthal genes weren't just random evolutionary baggage, many of them were beneficial. They gave our ancestors a crucial survival advantage as they moved into new, harsher environments. Genes related to a stronger immune system, for example, helped our ancestors fight off local pathogens that Neanderthals had already adapted to over millennia. Other genes influenced our skin's response to ultraviolet radiation and our ability to cope with cold temperatures. In a very real sense, interbreeding with Neanderthals was an evolutionary shortcut, a toolkit for survival in a new world. But what about the Denisovans? The story gets even more fascinating. As modern humans continued their push eastward into Asia and Oceania, they met the elusive Denisovans, and they interbred with them too. Today, the highest percentage of Denisovan DNA is found in populations in Melanesia, including Papua New Guinea and Australia, where it can be as high as 6%. This suggests a significant and prolonged period of interaction in Southeast Asia. Just like with the Neanderthals, these Denisovan genes conferred powerful advantages. One of the most incredible examples is a gene variant found in modern Tibetans that allows them to thrive at high altitudes with low oxygen levels. Where did they get it? From the Denisovans. This ancient inheritance is a key reason why people can live on the roof of the world. It's a ghost of our ancient past, shaping human biology in the present day. The discovery of these interbreeding events has completely shattered the old linear model of human evolution. Our family tree is not a simple branching structure, but a complex, braided stream. Rivers of different human populations diverged, then flowed back together, exchanging genetic information that would shape the future of our species. We are not pure Homo sapiens, we are hybrids, a mosaic of ancient lineage. This new understanding forces us to see Neanderthals and Denisovans in a new light. They were not failures. They were successful, intelligent, and adaptable populations that survived for hundreds of thousands of years. They had culture. They likely had language. They cared for their sick and elderly, and they buried their dead. Their world was rich and complex. Their legacy is not extinction, but continuation. Their story merged with our own. So, the next time you look in the mirror, remember that you are looking at a face that carries a deep history. A history of migration, of survival, and of connection. Within your DNA is a whisper from the Ice Age, a genetic echo of our ancient relatives who walked the earth long before us. Their journey didn't end 40,000 years ago in a cave. It continues within you, me, and billions of others across the globe. We are the living legacy of this incredible, interconnected human story. Thank you for joining us on this journey into our deep past. If you found this as fascinating as we do, make sure to like, subscribe, and hit the notification bell so you don't miss our next exploration.